Right, so guys, now we have to find the derivative of this function x power m. It asks you to find the derivative of any function who is having a power m, okay, where m is any sort of natural number, 1, 2, 3, any natural number, okay? So it actually asks you that whenever you are given a natural number as an exponent of a function x, how you have to find the derivative, okay? So that's the thing we are going to do today, and let's begin. If you have seen my previous videos, I've already told you that how you can find the derivative of such functions which are having an exponent over them. So we are going to apply the same technique over here too. So what is the first thing? You have to apply the increment and also in the dependent variable, okay? Now you have to move this y towards the right hand side of the equation, and it will become negative. And now you can simply put the value of y which we had already considered in the first step. What you have to do over here is that you have to look that what is present on this side of the equation, okay? It is actually x power m, so you have to take it out common, okay? And if you look at this thing over here, x power m is actually common, so you can take out 1. We will deal with this delta x a bit later because it's not common, so how we can tackle it, I will tell you later. This is x power m and this is exactly matching, so this is 1. So in order to take out delta x common from this x power m, you can simply write a x in the denominator, okay, and also a power above. Now you can simply apply the binomial series method, and that is going to be pretty easy. Okay, so what can we do? First of all, we have the 1, that's good. Now x divided by m plus m. Now the power is being subtracted by 1 divided by the 2 factorial, and now the square of delta x divided by x square, okay? And this term would be continuing. This can be raised up to 3 factorial, 4 factorial, okay? And the power would also change. That's another thing. I'm going to explain you binomial series or binomial expression in other videos. But for now, we are going to use this technique to find the derivative of the function. So we have minus 1 over here. This is the same minus 1 which I brought from this step, okay? So 1 and 1 are being cancelled, and what is remaining? X power m, and you can see that there's a delta x and there's a delta x, okay? So let me just write this thing over here, plus m. Now we have m minus 1 divided by 2 factorial, delta x square divided by x square. Now what I have to do, you can see that there's a delta x over here and there's a delta x over here, so you can simply take out common, okay? So we have taken out delta x common, and now what is remaining? M becomes m over x, okay? Because nothing is remaining over here, the thing which is remaining is 1, so m multiplied by 1 is 1. So m multiplied by 1 is m, so m divided by x plus m minus 1 divided by 2 factorial, and we took out delta x common, but actually it was delta x square, so delta x remains, okay? And the x square is as it is in the bottom. Now you can see that there is a delta x outside everything, and you can simply cancel out if you divide delta x on both sides. And I have told you from the beginning of this series that you have to simplify up to a point where you can take out delta x common from the entire thing, okay? So I am just rewriting this thing just to move towards my last step, okay? And what is the last step? Yep, that is bringing the limit into action, okay? So limit delta x approaches to 0, and there's also a limit present over here, dy divided by dx, and x power m is remaining. Wherever there's a delta x inside this equation, you can simply put a 0 over there. So there's only one delta x present in this entire equation, and that is over here. So if we put a 0 over here, this whole term is cancelled because 0 is being multiplied by everything present over here, okay? So this term is already cancelled, it becomes 0. So we are getting m divided by x. So this is the final derivative, m xm divided by x.